Hi, this is Paul Edwards with Danmark Company. I'm creating this video to give you an idea of how to troubleshoot or how to generally understand our two-part mixing system that can be used with multiple applications, whether it's going to be a two-part detergent, a two-part sanitizer, or a two-part antimicrobial intervention. But before I go on further, I want to give you an idea of what Danmark Company's general attitude is on safety. First of all, in the food industry that we serve, we want to impress upon our customers and those watching this video that safety always comes first. So our number one rule is always wear safety glasses and nitrile gloves when you're around the equipment, okay? So when you're around the two-part system, you need to wear safety glasses and nitrile gloves. Rule number two, test your equipment with water first, okay? When you're running water through your system, you can test what the flow rates are, you can test what the draw rate is, you can test all the moving parts of your system. So there's no need to run a hazardous chemical through your system when you're testing it, okay? So as a number two rule is always test with water. The third rule is once you're done with your equipment testing, then you start to approach your mixing of chemistry, which are generally hazardous materials, then we need you to go on and take the most amount of precaution as you possibly can. And that precaution starts with titration. So you don't want to be working with a chemistry that is going to be applied on a surface, whether it's a surface of your hard contact surface for a sanitizing purpose, or whether it's a hard surface for detergent application, whether it's a hard surface for, or a food product surface, okay, such as beef, pork, poultry, produce, seafood. You want to make sure that that concentration is correct, and you use a test kit provided by your manufacturer to determine that, okay? And finally, we want to thank you for your business that is safety first driven, okay? So we are very appreciative of your business that is safety first driven. Thank you. Okay, I'm Paul, I'm back. So basically what I have here is the two-part system configuration, and I've got to ask for pardon up front. These are my tripod legs here for my camera, so they're not a part of the system, okay? They're just holding my camera in place. I can do my training and answer what would be potential questions for you in advance. So as you look at the system here, you notice that I have a MiniDos pump. This is a pump I've been using for over 15 years. I'm very familiar with it. I like it. There are other pumps out there that are very, very good pumps. But for the purpose of my speccing out a pump for my system design, this is it right here. This is the pump I go with, okay? So what I have is I have quick disconnect unions here. I have a quick disconnect union here. Of course, with this MiniDos pump, you have the tube that's, and I'll be talking about this, but this is the tube that draws the chemistry up. And then here you have the quick disconnect union that's connected to a inline filter system. Okay, so basically think of it this way. Your water comes in on this side, okay? This is your inlet side. The water comes in, it's being drawn by water hydrodynamics. So when you have water pressure coming in and this pump is drawing, okay, because there's flow going through this, knock my little camera there. I don't want to knock it off the table. So anyway, the water pump is going up and down, and it draws the chemistry as this water passes through it. And then it goes into this mixing chamber. So basically what happens is this water and the chemistry is combined in this mixing chamber and acts as a static mixer. And then it comes out, and then here you have your little valve for taking your sample. And then this right here would go out to your hand wands, if you have hand wands. So if you're a boning operation, a boning table, that you're taking off the bone and you want to spray your trim coming off the bone, those hand wands would be down further. I've had configurations set up where we've had 4 hand wands, we've had 6 hand wands, we've had 8 hand wands. The nice thing is that once you've moved past your sampling port, that's ready to go. That's ready to be used. That's ready to apply chemistry. So that can be applied directly on a spray cabinet, whether it's a smaller spray cabinet for primals or a large spray cabinet for carcasses. All of that can happen downstream. And so basically what you have is all that going on downstream. But really I'm talking about right now is just this particular area here where the configuration is concerned. So the filter is there to act as a static mixer, but also to protect your nozzles from debris that could plug them up. Okay, so now what I'm going to do is I'm going to take this down closer, and we'll start looking at this setup here on a more closer dynamic. Thank you. Okay, so now we're closer. This is the inlet side of the Dosamatic pump. And when you start talking about why a union, quick disconnect union and so forth, and the things that are going on prior to here, a couple of things you need to realize is that these quick disconnects are really great for disassembling the pump. You know, if you're gonna have to replace this pump, these quick disconnects really work extremely well in taking the pump off without changing plumbing significantly. So that's the one other thing. Remember that prior to your pump, you're always going to have a ball valve, okay? The ball valve is to turn off your water supply to this. So every plumbing operation where they put in the plumbing for this must have a ball valve connected to that right there. Now this is a 1-inch inlet on this here. This inlet here of the quick disconnect, I'm verifying, I'm looking, this is a 1-inch, okay? Could be if I'm wrong, it could be a 3/4 inch, but I'm pretty sure that's a 1-inch, okay? I'm looking at the writing on that to see what it is, but I'd have to look at my spec sheet, but I'm pretty sure that's a 1-inch inlet, but it could be a 3/4 inch, guys, or gals. So anyway, you've got a ball valve. The ball valve turns as your main water turn off, okay, to this system, okay? So as the water's coming in on your inlet side, this pump is going up and down. There's a motor in here. It's moving up and down, and in that up and down, it's drawing the chemistry here. And if you'll look right there, and I'll do a little close-up here. You see that right there? That right there is what meters your concentration, okay? So that's right there is what's going to take your, and I'm going to give you an example. If you have a 9.4% sodium chloride and you're running an acidified sodium chloride program, this right here will get you to the parts per million you want, whether it's a parts per million of 180 parts per million or a parts per million of 1200 parts per million. That's what that's for. It's to meter your chemistry to that level. Now, I'm not going to be talking about activation yet, but I just want to tell you that that's the purpose of that, is to meter the concentration you want. And as I said on the safety first, you do that before you apply to your intended part. You see the quick disconnect here? Now what I'm going to do is I'm going to go on and take a break, and I'm going to move over with the camera. Okay. Okay, so now we're back to the filter system. I call it my mixing chamber. The mixing chamber is right here. It's got some adjustments here on the top to open and close or bypass this water flow. So you actually can go on and put it over here where you bypass. Here where no water is moving through it because you want to change out something, maybe clean out debris. So you put this little connector here, you put it right there in the middle. Or you go here and that says filter, so that's filtering everything, acting like a static mixer. And then out here you have your outlet. It says out, it says in, and then it comes out. So that's it. Now I can see to the right, you can see the sampling port. Okay, so this is a sampling port. Every one of the Danmar systems is going to have a sampling port because we want you to be able to test your chemistry right by the pump. Okay, but it isn't uncommon that people will go on and test their chemistry coming out of their hand wands or testing their chemistry coming out of their spray nozzle from their spray cabinet. We have what's called a bucket test that we do. And the reason why is because in some chemistries, the activation, particularly in acidified sodium chloride, where we deal with, you may have a chlorine dioxide residual that you're going to be testing for. And that free chlorine dioxide, we have a test kit for measuring free chlorine dioxide. We want to make sure that the free chlorine dioxide is within our supporting documentation. So you might want to test it from here, but then all of a sudden you want to go on and get an idea if at the spray nozzles what you're getting in the bucket test, which bucket test is a 5-gallon bucket put underneath the bottle of the spray nozzle, and you're collecting what's running through that spray nozzle. You collect it and then you test it, and you're generally speaking, because chlorine dioxide is a gas and it's forced through a spray nozzle, there may be some loss, but I've never seen a loss of free chlorine dioxide greater than 20%, and that was very rare. Generally speaking, I see anywhere from a 10 to a 15% loss. When you're looking at a concentration of 20 parts per million, 10% loss is 2 parts per million, and a 20% part would be 4 parts per million, you know, so forth. Okay, so basically you're looking at 20 parts per million, you're looking at about a 4 part per million drop at 20%. Okay, did that make sense to somebody out there? Okay, so anyway, that's pretty much it. What I want to do here is I want to talk about this right here. This is my valve. Tell you what I'm going to do is I'm going to go on and put a pause here and focus or magnify down into that. Hold a second. Okay, back to our safety first theme. You'll notice here that this valve here is on the off position, and then here's your little what does it call that? The reduced end right there. It's oh goodness, what is that? It's there's a term for that. I apologize, it skipped me. But anyway, you've got a 1/4 inch that's reduced down to probably an 1/8 inch orifice. Okay, so with the pressure that's built up in the system, that's going to cause a significant spray coming out that's your sample. You don't need to be blasted with a sample that's coming out of this. Okay, so what I'm recommending is just slightly open it like this. Okay, and so that your sample comes out in a small flow rate and a small amount of pressure, so that you could collect it in a cup of, like, let's say 8 ounces. So you go out, you have an 8-ounce cup, you're going to fill it up with this chemical, but you don't want it to spray you. You got safety glasses on, you got nitrile gloves on, but you still don't want to be sprayed in the face, right? So you just barely open that, okay? Don't fully open it. That's fully open. You don't need it to be fully open. Just cock it open a little bit like that and accumulate 8 ounces, okay? I'm getting to the final portion of this. Bear with me. Okay, we're at the very end of this configuration, and let's see here, right there. Okay, and I'm trying to get this tripod not to fall. I apologize. Hope you don't get seasick from all this. Okay, there you are. Good, perfect. So you got the outlet side here, okay? And a lot of people make the mistake of running that directly into a spray cabinet, running that directly into a hand wands, running that directly into whatever, okay? But in our plumbing recommendations, we have a plumbing recommendation out there that you can look at. It's a general plumbing recommendation. We always recommend putting in a ball valve here. So technically what you're looking at is you're looking at having multiple ball valve ports, okay? So keep that in mind. We want you to have multiple ball valves for your safety. Ball valves in a line mean safety because you can turn it off at the point closest to the area that you're working. So when you have a ball valve at the beginning on the inlet side of this system, you can turn off and you can work on the pump. When you have a ball valve at the very end of this system at the outlet side, you can turn it off and start working with equipment beyond that, where you can work with spray cabinets, you can work with, so you want to be able to turn off right here, because when you turn it off right here, you're basically you have no way that you have chemistry going beyond that point, because you've turned it off right there, okay? Remember, water first, water only, so that will be the case. Now, I know somebody up there is raising their hand and they're saying, Paul, how come you don't recommend a bypass here? How come you don't have a bypass here? Well, actually, if you look at the plumbing diagram that we send out, we do have a bypass. So on the inlet to the in the inlet of this system here, which this is our MiniDos system, we show on our plumbing diagram that you actually literally have a water bypass that goes to the top. Okay, so let me go on and try to demonstrate what that would look like. Okay, so we're back to the big view of this system here. Okay, so imagine a water line, a 1-inch water line coming here, okay? And right at the ball valve right here, let's say you have a ball valve here. Right here you have a T. The T would take your water up, take it all the way back over here. So T means that you've got a water stream that's going to go up and above it and across it, and then it's going to come back down. You're going to have a 90 here and a 90 here, and then you come back in and you have a T right here, okay? So guess what? You're going to have a ball valve there and a ball valve right there just for your T, just for your bypass. So you're going to have a ball valve there and a ball valve there. You're going to have your bypass going over the top. So now all of a sudden you have water coming in, bypass, water going all around the system, coming down, water right here, bypass, all this system, moving past to your spray cabinet, okay? So on our plumbing diagram, we do show that. But when we ship this equipment out to you prior to plumbing, this is what it looks like, okay? So now I'm going to be talking specifically of your chemistry that you're sucking up. And the chemistry that I'm going to be speaking of particularly today is citric acid and sodium chloride. So I'll be discussing that next. Thank you. Okay, folks, I'm back and I'm wrapping it up. You may recall that right here I showed you that we had a little piece of tubing that is hanging here off the pump, okay? Well, basically, that tubing would connect to this right here, okay? So it connects right here, bam, okay? And you're wondering, Paul, what are these right here, okay? These are activation chambers. So whereas we have a static mixing chamber, we have activation chambers. What does this activation chamber do, okay? So let's work from the bottom up on this, okay? So when I come to the bottom here, what do we see? We see a filter check valve, okay? So at the very end of the tubing, we have a filter check valve. That's going to filter out debris. It's got a built-in check valve in here so that it makes sure that the chemistry, once sucked in, is not going to drain out. Every one of your systems have got to have a filter check valve. You have a ceramic weight. What does that do? It holds the solution down underneath in the 5-gallon pail. It holds the solution, holds this filter check valve underneath the solution, okay? So you always want to make sure that you got plenty of chemistry in the pail or the drum in order to have this underneath it, okay? And then when we move up that line, what else do we find? We find a, once again, another inline check valve, okay? And this check valve right here, let me go on and bring this in here a little closer, okay? I want you to see something. See what I've done here? Can you see that? See that I've painted with the permanent marker this one side, okay? If you look at it from a side, you see how it has a beveled appearance right here? You see how that's flat, this is beveled? Okay, this is your inlet side, okay? This is where the chemical's coming in from, okay? See my little filter check valve here? Bam! Okay, it's coming in, it's sucking in, bam, it comes through. Gets to this point right here, hits another check valve. So it comes in here, it's not going to go that way. It's just going to stay this way. It's going to keep sucking in. So that bevel is telling you that this is the outlet side of this check valve. That's the inlet side. There's no arrow here, so I go on and I paint or color or ink in that section there. It comes in. Then it comes in here. This is a Y fitting, okay? It'll be on the parts list. This Y fitting will accept right in there, screwed in, additional metering tips, okay? So that gives you more finality of control. That's what I like about my design here. Oops, almost lost my camera here. Gotta lose weight because I hit it with my gut. Okay, no, you know what? It's a balancing issue here. Let me get this corrected real quick here. Okay, yeah, it's a balancing issue, okay. I think I may have that resolved, maybe not. Okay, there, perfect. Okay, great. So as I said, these two will accept metering tips where you can go on and control that. And then you have your activation chambers that will connect to the bottom. Okay, so wow. Okay, we got through that little escapade of balancing and gut pushing. So here's where we're at. Okay, so we've got this system here. And you know a couple of things for sure with this system. You're drawing in two chemicals. Let me tell you what we've spec'd out at Danmar. We've spec'd out a citric acid 2%, and there's a reason why we did that. Okay, what we don't want is we do not want tips on this. Okay, we do not want tips here on this unless they're needed. Okay. So that finite control is not something that we do initially, okay? So we have a 2% by weight citric acid liquid that gets sucked up into this line right here, okay? There's no metering tip, okay? That pH of that acid is 2.5 pH, okay? So you have 2.5 pH being sucked up to be mixed directly with the sodium chloride. The sodium chloride is a pH of 10, okay? The pH of 10. So the sodium chloride gets sucked up right in here also, so now you have sodium chloride and citric acid. The citric acid is correct at pH of 2.5. The sodium chloride is correct at a pH of 10. They both get drawn up into your activation chambers. Those activation chambers create a residence time so that the two will combine and convert quite quickly into free chlorine dioxide. And then that free chlorine dioxide will go in and be drawn in by the pump and applied at the correct parts per million to the section that you want, okay? So now let's talk about some what-if scenarios. Let's say that your spray cabinet was moving chemistry through that in such a way that the activation may not be keeping up with the demand by the spray cabinet. Well, then this design would not work, okay? So if you had a situation where you've got 18 or 20 or 25 or 30 spray nozzles and you have this significant flow rate, this configuration would not work at all. None of this would work, okay? So I'm not going to be trying to convince you that it would, okay? We have other equipment that are high volume, high activation systems But that's not what this is designed for. This right here is designed for a spray cabinet that's got no more than 5 or 6 nozzles in it, and that those nozzles are spraying at a minimal flow rate, primarily because their nozzle specifications are really small, and the amount of chemistry that's being applied on that surface is minimal. I can tell you this, that I have validated studies that were shelf life enhancement chemistries that were 2 ounces a minute, okay? Believe it or not, I've done that, okay? I've validated upwards of 32 ounces a minute flow rates, okay, coming out of the nozzle with the 2-second contact time. So what I'm saying to you, and I'm not going to get real scientific with you, is that we have validated many low concentration, low flow rate applications, because this system is designed for that, and it does very well for that, okay? But we have big customers, big plants, big carcasses, have a lot more nozzles. We don't use this system for them, okay? So just wanted to make sure you understood that. Well, look, I know I've gone over a lot of information, and I thank you for the purchase that you've made with Danmark Company, and I'm always available to help you, okay? We do not travel to our customers' locations unless we are scheduled in, and it may or may not be included on the price of what you're getting your chemistry, okay? So it may be that you'll need technical assistance, that you'll need us to come out there. We are consultants in that regard. We have errors and omissions coverage. We have product liability coverage. So, you know, these are costs that have to be passed on. There used to be a time where companies could absorb these costs, but insurance companies have gotten so outrageous with their expenses related to you know, consulting and on-site determination, that we have to pass that cost. So we have a variable cost associated with that. Okay, so just keep that in mind. But you know what? We're available on the phone. Our troubleshooting checklist is very helpful. So there's no real need to say, hey, I have to have you out here. Unless you're willing to pay for it, then you really don't need to have us out there, because we can do this on the phone. It's very simplified system here to help you. Okay? So anyway, you've got my number, you've got my email address. If you send me your questions, thank you very much. Remember, safety first, and God bless.